Welcome to this introductory talk delivering the Chemistry A-Level offered at Old Swinford Hospital 6th Form. If you've got any questions that follow this, you can contact the subject leader, Mr. Sani, or you can contact myself and we'll be able to get back to you with any questions or queries that you may have. The course that's on offer with chemistry at OSH is the AQA exam board, and what we'd suggest that you do is that you go onto the AQA specification which is available online and start having a look through the paper. Now the chemistry course might be a little bit different to perhaps what you're used to at GCSE standard or for some of your other subjects, because actually it's interesting to see how the papers operate. There are 3 papers overall. The first 2 are worth 35% and the final one is worth 30%. But actually what's delivered and what's taught in those particular components is actually some things that are taught throughout the whole 2-year process. So physical chemistry will be in all 3 papers, inorganic chemistry will be in papers 1 and 3, organic will be in 2 and 3, and practicals will be in paper 3, but they'll also encompass lots of the material in papers 1 and 2. The assessment for each one is based on 3 written papers, they're 2 hours each, and they consist of multiple short and long questions. And if you have a look at the AQA website, you can see a little bit about each particular paper, but perhaps the best way of looking at this particular course is to break it down into the 3 different strands that comprise all 3 papers really. So the component of chemistry which overlaps into all 3 of the papers is physical chemistry, and that's the explanation as to why the materials around us behave the way that they do. Physical chemistry is great for those students that are combining chemistry with mathematics or chemistry with physics, because there is a certain degree of overlap there. This is the component that will explain why oxygen is a gas at room temperature, or why water is the key to life, why metal conducts electricity. If you do that physical chemistry component and you understand, the modules that are being taught there, you'll have an understanding about those key questions to life. The 2 areas which are, well, 3 areas really, which are most important and are the building blocks to your entire chemistry course are understanding atomic structure, electron configuration and bonding. And really over the summer period they would be useful for you to just go over, make sure that you understand the basics or the GCSE level. So with bonding you should know about ionic and covalent bonding, and make sure that you've got those basics ready to hit the ground running for A-level study. You'll also look at periodicity, so looking at the periodic table, and there will be a fair amount of calculations that take place under that physical chemistry component. The second thing that you'll be looking at is organic chemistry, and we can essentially call that carbon-based chemistry. So anything really with carbon as part of the chemical structure. And this is the component for chemistry which links into perhaps studying chemistry further afield in areas like pharmacy or chemical engineering. As part of the course you'll be looking at how crude oil is used to get fuels and to get plastics, and how the structure of carbon-based molecules can be adapted. So one of the required practicals that you'll be studying as part of the organic chemistry module will be the synthesis of organic chemicals, and specifically you'll be looking at how to make aspirin. So you will be making that particular drug. And finally, the third component is about inorganic chemistry. So we can roughly say that that's any element or structure that doesn't necessarily involve carbon or oxygen. So you'll be looking at the behaviour of the group 1 elements of the alkaline metals, the group 2 the alkaline earth metals, the third group transition metals, group 7 the halogens, and you'll be trying to look at the trends, why they have particular features, what characteristics do they share. This is particularly useful for anyone that wants to go forward and look at topics like geology or earth sciences. And really what I'm trying to explain from going through those 3 different areas is that they are all intrinsically linked, but as chemists at an advanced level you should start also seeing the subtle differences in between, and also starting to understand the specialisation that can take place within that overall study of chemistry. And if you're looking to further your studies and do an undergraduate based degree in something that relates to chemistry or pertains to chemistry, you can see that inorganic, physical and organic chemistry, they all have slight subtle variations that you might wish to specialise in. The department is quite a big department because of the popularity of the subject. So Mr. Sani is the subject leader, we have Mr. Pardo, Mr. Kerr, Miss Davis, they're all heavily involved in the support sessions that are available, and even if one of those isn't necessarily your teacher in Year 12, I'm sure that you'll get to know them, because the department, in terms of the support across all of the science subjects, is extensive. Our student satisfaction in 2019 and 20 in our student feedback was extensive with chemistry. The amount of feedback that we got from students commenting on the approachability of members of staff, commenting on the ways in which the lessons differed and the variety of tasks and the variety of lesson styles that were available to them to make sure that things were kept interesting, really stood out as being noticeable. The overall pass rate is above the national level, which you would expect. Class sizes are relatively small as well, and the teachers are specialists in certain components within chemistry, so you'll be able to get certain amounts of specialist understanding for certain areas, and those intervention strategies and those support classes reflect that. There are a variety of different extracurricular opportunities available within the department. There are trips, and there are obviously a lot of required practicals that you have to do, which are made to be as exciting as they possibly can be, and there's things like the Chemistry Olympiad, and you can see in terms of the chemistry prize winners over the past few years, you can see a variety of different destinations, but you can see that consistent level of high marks. So the requirements to study chemistry at A level are that you meet the minimum entry requirements for the school, and that you also get a grade 6 in chemistry and either grade 6 in one of the science or a double grade 6 in total. You also need to make sure that you get a grade 5 in your maths, and if you want to have a look at the subject specific requirements on the admissions page, just to double check that and have a look at all the others, then that would be worth your time. But if you're looking to do chemistry at advanced level, obviously we'd expect you to be hitting that grade 6, but those desirable traits are equally as important. You're going to have to confidently handle laboratory apparatus. That's something that is very, very clear about the advanced level course in chemistry, and you need to make sure that therefore you're quite diligent, that you're responsible, but also that you're able to process different kinds of skills and different competencies. So being able to process mathematical data is a significant advantage, particularly for the physical chemistry component. The idea that you're also going above and beyond what is expected in the lesson, that you're furthering your understanding about the key debates to be had in chemistry at the moment, that's a real advantage for you. Now, chemistry is classified as a facilitating subject. It's one of our most popular subjects at OSH, and the reason for that is because it directly is linked to certain career pathways, and it's seen as a requirement. So if you want to study medicine, dentistry, pharmacy, veterinary science, forensic science, biochemistry, chemical engineering, then you will need to study chemistry at A level. And what I would suggest that you do is, if you are umming and ahhing and you're unsure about whether or not you want to do chemistry as an A level course, have a look on University of Birmingham and University of Wolverhampton and other local Birmingham-based universities. Have a look at their course pages, have a look at maybe some careers or courses that you're interested in. Likewise, have a look at some higher and degree apprenticeship providers and see whether they require chemistry. Because what you don't want is to start your A-levels and then realise, oh, actually I needed to study chemistry. So case in point for that one would be myself. I wanted to do genetics at university, and when I was going around applying in the specific universities that I was looking at, they said that chemistry would have been something that they would have required from my A-levels, and because I didn't study chemistry at A-level, I studied only biology, I wasn't able to go down that particular pathway. So it's important that you do that in advance, and you can do that now over the summer period. In terms of pathways going into, well, as I've already mentioned and alluded to, those particular areas of medicine, dentistry, veterinary science, students tend to combine biology and chemistry together with that, and biology, chemistry and maths is a very popular combination amongst our students because they all interlink in different respects. Having a good understanding of how to interpret statistics from your mathematics component will help with chemistry, it will help with biology, but likewise you don't have to just do that combination. You can see that we've got Harry and Emily, for example, who've combined chemistry with physics. Physics and chemistry, and the physical chemistry component is particularly useful, and you can see obviously the success that they had with that. Dan's an interesting example as well, because he combined biology and chemistry with German. So you don't have to necessarily just do chemistry with biology and chemistry with mathematics. We've got a student in year 12, for example, who's currently studying history, politics and chemistry. So it doesn't necessarily need to be combined with one of those subjects. Now, for the summer, it's important that you are continuing with a little bit of work for your chemistry studies. So I'm going to go through some expected tasks for you to have a go at, and then also talk about the essential bridging tasks for chemistry. Seneca as a website, as we've already alluded to, is very useful. The AQA GCSE higher paper would give you a good grounding again, and some good revision activities to make sure that those foundations are secure before you go on to the A-level course. So again, looking at things like bonding, electron configuration, those things would be useful to just make sure that you've gone over before you start your A-level course. Something that Mr. Sani has specifically stated as well, it would be useful for you to take some of those materials from your GCSE study and try and produce a report going through one of these particular things. So organic chemistry, so as we've already mentioned, naming and chemical reactions. Group 7, which is important obviously for the inorganic components of the halogens, and then also looking at bonding specifically, so those giant covalent structures, differences between things like diamond and graphite, for example. If you're interested in that, Manchester University's got some really good detailed papers which are on graphite as a structure, and Britain was a world-leading player in the development of graphite and graphene over the past 10 years. Obviously, at A-level standard, what you should be doing is you should not just be doing the work that your teachers are saying, you should be going above and beyond that by broadening your subject horizons. And if you want to get a little bit of a head start, if you go onto the Royal Society of Chemistry, you go onto their periodic table podcast, you can actually find out information about all of the different chemical elements. And again, it'd be useful perhaps to look at the halogen group or group 1, for example. They would be useful areas maybe to start on. Another good place for you to have a look at to broaden those subject horizons, obviously you've got different scientific journals, New Scientist for example, but ChemGuide is an excellent website. It doesn't look necessarily attractive in terms of its overall design, but it's got some really good basic groundings in all of the areas that you'll need for A-level, and you'll be using it a lot over the course of the next 2 years, I'm sure, if you do decide to continue with chemistry. Finally, the essential tasks for the chemistry course in September. So these are the things that you must do. You must do the middle task. So what we want you to do is we want you to write and design a 1-page cover page to go to the front of your folder for chemistry in September. So something that can make you, if you lose your folder or if you put your folder out somewhere, you know that it's yours. But within that, you need to ensure that you've got descriptions and images, so label diagrams of a mole, ionic bonding, covalent bonding, metallic bonding, periods and groups in the periodic table, which we've already referred to. The other tasks that you could do, you could choose 2 from any of the ones that are around the outside. So you could create a model to showcase an isomer, and this can be conceptual in its design, so it doesn't have to be specifically designed according to the first Google image that you see. You could choose a metaphor or an allegory, for example. You could obtain a copy of Chemistry Review or New Scientist and write a summary of one interesting article that pertains to chemistry. You could make a poster of an atom for a Key Stage 4 student. That would be a really good exercise for you to just go over the groundings of the atomic structure. You could describe the main differences of the properties and uses of the alkali metals and the transition metals. So it's basically just a Venn diagram of sorts of here are the similarities, here are the differences. 300 words isn't that much at all. You're talking about half a page of writing. You could research and describe how aspirin could be synthesized using normal laboratory apparatus. That is something that you will be doing as part of your chemistry A-level, so you can get ahead with that. And if you are interested, you might want to read a book which is called Blitzed, and it's the study of how Nazi Germany really got involved in the pharmaceutical industry, and particularly with drugs, because aspirin is a German drug. It was invented by the Bayer pharmaceutical industry at the exact same time, really. I think it's a week apart from another famous drug called heroin. So if you are interested, you might want to do some research about how aspirin was created, how it's synthesized in that first instance. The next task is a conceptual task to make sure that you remember the structure of an atom, an isotope, and an ion. So you can do it in the form of a mnemonic, a rap, a poem, a song, a parody. Essentially, it's a way in which you can remember that structure and it's embedded in your mind. Common thing for you to be doing at GCSE higher level when you're revising for those examinations. We'd like to potentially find 5 common chemistry misconceptions on YouTube and ask 5 to 10 people their understanding, and you could write a brief report on their findings, so things that people tend to get wrong when it comes to chemistry. And then finally, chemistry is more important than biology when studying medicine. It's a discursive essay, so you need to understand, or you need to argue perhaps, why chemistry is such an important subject for people who are going into that particular pathway. And if that's something that you want to do, that's a really good task for you to do in preparation for your Pathways to Medicine scheme. If you've got any questions from anything today, just make sure that you get in touch with either Mr. Sani or myself. And what I'd suggest that you do before you start watching your next video is that you have a look at some of those materials that have been advertised. So, for example, the periodic table from the Royal Society of Chemistry, and you start making a note and a bookmark of a few of those articles. Thank you very much for listening and watching.